Phil. Hello, everyone. I'm Alison. I'm from UNSW, and I am here tonight to give you a taste of quantum physics. So there's a lot of people in the room that might have heard of quantum physics before, but just in case, we should make sure we all start off on the same page. What is quantum? Well, quantum is a word that you put in front of things to make them sound cool. Things like batteries, dishwashing tablets, even myself. Of course, this is a joke. What we really mean by quantum is we're talking about tiny things, atoms, electrons, the nanoscale. And to help you visualize how small this nanoscale is, I want you to picture a blueberry. And did you know, fun fact, a blueberry is halfway in size between the world and an atom.
Whoa.
The humble blueberry. But we need to make this slide more scientifically accurate. So instead of this nice cartoon of an atom, we're going to replace it by a big fuzzy ball of uncertainty. And now we've got quantum physics. So that's the first question that people have. What is quantum? The second question that people often have at this point is, well, what is it useful for? So let me tell you that you can use quantum for three things. For example, you can use it to build some fancy computers that we just heard a bit about that. You can use it to sense really tiny changes in things like magnetic fields, time, gravity. You can even use it to secretly transmit your top secret information, such as where to find the best free food on campus using quantum technology. So that's very cool. But there is a third question that people have about quantum physics, and it's often not addressed. So it's really important tonight that we address this crucial question, which is quantum physics yummy? Now, you can't just believe anything you hear, right? You want to make sure that you collect data yourself. And so tonight we're going to do an experiment together to find out whether quantum physics is yummy. So in order to make this experiment work, I'm going to ask for 3 brave volunteers to come and help me with my buffet of case studies to try. So who's keen to come up? Right, 1, 2, 3. All right, come up. You've been chosen. Well done. All right, so I want you guys to just stand down here, and we're going to get a whiteboard. Phil's going to help me with this. So maybe you might want to stand over here. This is great. This is great.
Matt, can you give me a white screen?
White screen. Okay. So we're going to do an experiment tonight to find out if quantum physics is yummy or not. We have 8 data points to put on this board of whether it is yummy or not yummy. So I've still got slides, which is the tricky part, but they'll go behind you. Let's go back to this blueberry. The first item that we're going to try tonight is a blueberry. So this is your first taste of quantum physics. I want you to each try a blueberry.
While they're trying a blueberry, what number are you looking for? 38.
38.
38.
Up the back.
Up the back.
All right. Did you get one? Okay. So is it yummy?
That was a brilliant blueberry.
Yummy?
Yummy.
Yummy?
Yes.
Okay, we've got 1 point for yes. Great, thank you. We're going to do
3
tallies.
points, just one.
Just one. We're agreeing. It's a repeatability. Yep. Yes. Well, if 2 of you said that it was, one wouldn't. It was super yummy.
Preferences?
Well, there's 3 for a reason, so we should get a consensus. Okay. Let's go back to those applications. Did you know that all 3 of these applications can be achieved using the quantum properties of light? So it's really important that we think about what light tastes like. And I happen to have here a bottle that says on the front, light taste. Light taste. So we're going to try this. Grab a cracker.
Do we have to?
This is for science, Ken.
It's for science. Just dip a cracker in there. Yep. It is.
Delish.
All right, what have we got? Goes better the quicker you go.
No.
Yummy.
Yummy.
All right, we got another yummy. Didn't expect that one. Very good.
Yeah.
So let me tell you about what we do in the lab. We have some samples and we need to make them really cold. What do you do when you want to make something cold? Yep. Freeze or maybe just fridge. That'd do. So we put them in the fridge. This is what a quantum fridge looks like. You saw this before. Gets you down to just a fraction of a degree above absolute zero, which for reference is even colder than Scotland. Some people say it looks like a chandelier. I say it looks like a wedding cake. So this is not a wedding cake, but it is a cake.
Hey.
Oh wow.
Go quick.
What are our presenters' names?
Yeah, shall we have names? They got mouthfuls of
I
food.
know, I timed that badly. didn't
We got nods. Okay, another point for Yummy.
I? Okay.
Great. Okay, so what we do with our fridges, other than thinking about food all day, this is me in the lab thinking about food, is we study some photon sources. But I'm not talking about tomato, barbecue, Worcestershire sauce, however you pronounce that. I'm talking about single photon sources, the type that give you photons on demand. Now, these sources are made from erbium implanted into silicon, which both happen to be highly lickable, according to the periodic table of lickability. And so we put the erbium in the silicon, and I have here some erbium in silicon. It's not actually erbium, it's just sherbet.
Amazing.
Erbium sherbet. Nodding. All right, we are on fire here. Let's keep going. So what we want to do with our erbium in silicon single photon sources is find the most interesting flavor of photon by photoluminescence here. So we shine a laser, the erbium is in the excited state, comes back down, gives us a nice photon. And we are going to look for the most interesting flavors of photon. So what I have here is a nice mix of flavors, just like how we have a nice mix of photon flavors in our sources. So give this one a go, and I'm not going to tell you what it is. You can, you're not allergic to anything, are you? Very good.
You're not allergic to arsenic, are you?
Can you tell what's in the sauce? It's not pumpkin. No. Is it yummy, more importantly?
Yeah.
Yeah, still yummy.
That is yummy.
Okay, we're on fire. Let's keep going with yummy. Very good. What we have here in this, I'm going to tell you the answer. We got honey, ginger, and chili, my little concoction that I made at home last night. And this is what our photon sources look like, a nice cocktail of interesting flavors. So what we're doing in the lab is we're studying these different flavors, figure out which ones to study based on whether they're interesting, if they have a small line width, if you're in the know about that, and which ones linger the longest, which is called coherence. In order to detect these photon sources, we need some taste buds in the lab, by which we call photodetectors. These are made of superconducting nanowires, and they have a whole bunch of different layers to make them work. Each layer serves a certain purpose. We draw little artworks in the layers. So they remind me of nano sandwiches. And we are going to try some nano sandwiches. Little gummy burgers.
Read it out.
Trolley gummy burger.
Who here has ever had a gummy burger before?
Who's not keen and wants to try one? Who's not had one and wants to try one? Yep, all right. Good job. So once you've had a try, we need to know if it's yummy. Same deal as before. We've got one yes, second yes, third yes. All right. You guys are easy to please. So these are our nano sandwiches. Really a lot of things we study in the lab is related to food. If it's a big sample, we call it a wafer. So second last one, wafers. You guys are all sad you didn't volunteer, right? You can have some at break. Yum. All right, we're all good with that. If it's a tiny sample, we call it a chip. You've hardly finished the last one. All right. Is it yummy?
Yes.
Yes?
Right. Yummy.
Yes.
Yummy.
All right. We got full marks here. Fantastic. So the results are in, and you don't have to just believe me. We've done the experiment together, and we have determined that quantum physics is in fact rather yummy. 100%. Well done. Thank you, volunteers. I'll leave this somewhere in a break in case other people want to try. So just a final closing word. Thank you. Please feel free to go back. A final closing word. So after all of these years of hard work, of study, of being a woman and trying to smash gender stereotypes, glass ceilings, here I am. I'm a woman in a kitchen, making sandwiches and sauces. But at least it's a fun quantum kitchen. We're cooking up a quantum storm, serving up some amazing quantum dishes. So I hope I've whet your appetite tonight with my taste of quantum physics, and I hope you enjoy your night. Thanks.